Alright everyone, I'm making this short recap video for the exam that we didn't take right before, the week before what would have been spring break. So I just wanted to make this this recap video, number one, to make you guys aware of how I'm going to be delivering our information for this class from now on. Primarily, I'm going to be using this this whiteboard app and making videos like this and uploading them onto our eCampus page. And so I just wanted to, give you sort of a gentle introduction to what these things are going to look like, and also give you a very short recap of all the stuff that would have been on the exam had you taken it in class like we were supposed to. What's going to happen instead is that we're going to take it from the comfort of our own homes, and it's obviously going to be a different format than it was, but we're sort of figuring this all out as we go. So without further ado, I just want to say a few words about the big ideas from voting theory that we talked about before all of this craziness began. Alright, so the first thing I want to say is that this is going to be a very brief recap. I'm not going to get to talk about every single thing that we talked about in class. I really just want to give you the gist of what's going on. And you were all experts on this before spring break and the cancellation of classes happened. So this, should really just serve to jog your memory. Alright, so the first big topic we talked about was fairness in voting. And remember, the idea here was that voters submitted preference ballots, which we then compiled into a preference schedule, which were these big charts that had, all the different ballots that the voters submitted in each column, and at the top of the column was the number of voters that voted for that specific order of preferences. All right, so we've got these preference schedules, and the really two big ideas that are at play here are the methods for actually deciding who wins these elections, and going side by side but completely independently from the methods are these fairness criteria. Alright, so we had this idea that, or rather, I should say, economists and political scientists and mathematicians throughout history have had these ideas of what could or should make an election, be called fair in some sense. So, we had a long list of each one of these things. For the methods, we had, the method of plurality, which is just, whoever has the most first-place votes wins an election, taking no other preferences into account. We had this idea of instant runoff voting, where we had an algorithm to decide who wins the election, and this was where we systematically eliminated candidates, namely the candidate who has the fewest first-place votes gets eliminated first, and then you recompile the schedule and see if someone has a majority. If no one has a majority, then you keep repeating this process. The next one was a point system, which was called the Borda count method. And here, you assign 1 point for every last place vote, 2 points for every second to last place vote, and so on and so forth. And the last one, which was a sort of hybrid of the head-to-head matchups of Condorcet and a point system like Borda, was Copeland's method. All right, so this is where you look at the head-to-head matchups, just pitting one candidate against one at a time, And in those head-to-head matchups, you compare how many voters preferred one candidate over another, and whoever wins the head-to-head matchup gets 1 point. Whoever loses gets none, and in the case of a tie, each candidate would be awarded half a point each. All right, and then whoever has the most points at the end wins. So these are the 4 big methods that we talked about, and the 4 fairness criteria that we talked about. The first one we ever mentioned was Condorcet. And remember, these fairness criteria are hypothetical statements, right? These are like what should happen in an ideal world in terms of a fairness, a way of measuring fairness in an election. All right, so what Condorcet said was that if there is a candidate which wins every single one of its head-to-head matchups, then that candidate should win the election. And, we saw some examples like the city council election where we had a Condorcet candidate, so someone who won every one of their head-to-head matchups, but who lost by plurality, for instance. And they also lost by IRV. All right, so plurality and IRV both violate the Condorcet fairness criterion. And I'm not going to go through in detail every single one of these, but I just wanted to sort of remind you of how we went about deciding these things. All right, another one of the fairness criteria that we looked at was this monotonicity. And the idea there was that if voters change their preference in favor of a candidate, that candidate should not be harmed. And we saw that IRV violated monotonicity. All right, again, it was in the context of I think it was a PTA election, and some ballots were lost or destroyed or something, and some people bandwagoned onto who they thought was going to be the winner, and ended up costing the winner, the original winner, the election. All right. And again, purely hypothetical statements there. That's really what is the hallmark of a fairness criterion. All right, the next one was the majority criterion. And this is the one that says that if a candidate is favored in first place by more than half of the voters, then that candidate should win the election. And we brought this one up in the context of board account. We looked at an example that had, I think it was 4 car companies, and it was like Chevy or something had the majority of first place votes, but Toyota ended up winning by board account, or Hyundai. It was something like that. So BORDA violates the majority criterion. And the last one, which I think was maybe the most bizarre, was what we called IIA. This was the independence of irrelevant alternatives. And this is the one that says that if a non-winning candidate is removed from the election, the winner should not change because of that non-winning candidate being removed. All right, and we brought this one up in the context of Copeland. Copeland seemed like it was the perfect method. It satisfied Condorcet, monotonicity, and majority, and then it violated IIA. All right, so remember we had what I was calling a fairness chart that had all the methods along one side and all of the fairness criteria along another side. And, it was basically just filling in X's and check marks, understanding how all of these things interplayed with one another, right? So which methods violated and satisfied which criteria. Okay. So that was the big idea there. Not only understanding how to determine whether a certain method is or is not fair according to certain criteria, but also just straight up using the methods to determine who wins different elections. All right, so you've got to have both of those things in your back pocket. You've got to be comfortable with both analyzing the fairness of a certain method and also determining who wins based on Copeland's method or BORDA's method. All right. So The next big thing we talked about was this idea of weighted voting. And remember, the big difference here is that in the fairness section, we had voters submit preference schedules, and they had to submit preference schedules because there were typically a lot of candidates that were running to win this election. And so voters had different preferences for all of the different candidates that were out there. Well, in weighted voting, we remove the need for various preferences by just replacing everything with pass or fail. That's all. Anything is any election is just deciding between pass or fail. All right, so every single election is either yes or no. There are no preferences other than do you prefer yes or do you prefer no. All right, so things either pass or fail in these weighted elections. And remember that we call the voters players, and we denote them by, P1, P2, P3, and so on. And each of the players have weights, which is what, sort of the number of votes that they actually hold. And we call those W's, W1, W2, W3, and so on. And there's always a quota. Whoops. There's always a quota that needs to be satisfied, right? That needs to be met in order for a measure to pass. And we call that quota Q. So we had this shorthand for a weighted voting system where we put the quota first, and then we list the weights of the players, typically in descending order. So W1 is the largest, all the way down to WN, which would be the smallest. And so in a sense, you're putting the most important players first. And this is our shorthand for a weighted voting system. Now, as you hopefully remember, there were two big things to consider within a weighted voting system. There is the non-sequential. All right, so this is when the order of the votes does not matter. And what we do in this case, in order to determine how much power each voter has, and that's really the big thing that's going on here with the weighted scheme. We're not trying to figure out fairness anymore. We're instead trying to figure out power. All right, so in the non-sequential case, what we do is to list all the winning coalitions. Right, so these are the coalitions where you combine players in any order you want, because order doesn't matter for these coalitions. You just combine the players in any order you want, add up their weights, and see if their combined weights meet the quota or not. All right, so you list all the winning coalitions, and then you underline what we call the critical players. And the critical players are those whose, if you remove them from the winning coalition, the coalition no longer wins. All right, so they're important in that coalition. The coalition can't pass without them. All right, so you underline the critical players. Critical players in all these coalitions. And then to determine the power that each of these players has, the name for this power index is called the BPI, the Bontoff Power Index. And the idea here is that the BPI for player K is equal to the number of times that PK was critical divided by the number of times anyone was critical. All right, so it's like a ratio of the power. It's when all is said and done, it's the percentage of the power that this player holds in this given weighted voting system. All right, and there were some key words that we sort of threw around here. There was this idea of a dictator. that's anyone who has 100% of the power. There is this sort of more nuanced idea of being very powerful, but maybe not having 100% of the power. And this was the idea of having veto power. And this just means that no measure can pass without that player's support. In other words, they could veto anything if they wanted to. And at the other end of the spectrum, we have the idea of dummies, which are players that have zero power. They might as well not even be in the system because they don't have any real say over what happens. Alright, so these are the big ideas from the non-sequential case, where order did not matter. Right, so these winning coalitions that I mentioned here, right, in these winning coalitions, these are unordered. Right, so that means that we denote these with curly braces, if you remember. The coalition consisting of player 1 and player 2 is the same as the coalition consisting of player 2 and player 1. Right, they're the same coalition in the non-sequential case. And that's very different from the next setting, which is the last thing we talked about before classes were canceled, which is the sequential voting case. And what we look at in the sequential case is ordered coalitions. And remember, it's very important that these coalitions are all grand coalitions. Alright, so every one of these coalitions is a grand coalition, meaning that they consist of every single player. Alright, so we look at all the ordered grand coalitions. So, if for instance we had 4 players, then, one of these grand coalitions would look like all the players in order. And remember, these are ordered now, so this is a distinctly different coalition than, even just changing 2 of the players' orders. Alright, so what the first coalition means is that player 1 votes first, player 2 votes second, player 3 votes third, player 4 votes fourth. And this other coalition means that player 2 votes first, player 1 votes second, player 3 votes third, player 4 votes fourth. Alright, so the order matters for these ordered coalitions. And remember, we make them all grand coalitions just for simplicity, right? It's really just to make our lives easier. Because, as we pointed out in the last class that we had on Monday of last week, there are a lot of these things. Right? There are a ton of ordered coalitions, these sequential coalitions. All right, and if you remember, if there are n players, then the number of sequential coalitions is actually very large. It turns out to be n factorial, which is, n times n minus 1 times n minus 2, all the way down to times 2 and times 1. And these numbers grow very, very fast. All right, so if n is 3, there are 6 sequential coalitions. That's not bad. If n is 4, there are 24 sequential coalitions, which is a lot. If n is 5, there are 120 sequential coalitions. If n is 6, there are 720, and so on and so forth. It only gets worse from there. All right, so the idea here in determining power, right? How is power determined in sequential coalitions? Well, we had this other power index called the SSPI. This is the Shapley-Shubik power index. And the way I remember which one is which is that, the S's in SSPI work for the sequential coalitions. It's silly, but that's how I remember it. So the SSPI for player K, this is going to be the number of times player K is, we have a different word for it now because it's sequential as opposed to unsequential, or non-sequential. though a special word here is pivotal. All right, so the number of times player K is pivotal divided by the number of times anyone is pivotal. All right, and the notion of being pivotal, right? This is basically the same kind of idea as being critical, with the main difference being that since every coalition has to be grand in this case, every single coalition has every single player in it. The way we're going to identify who's important is as you go through the order of a coalition, right? Let's say we've got a coalition that looks like this. We identify pivotal players by underlining which player switches the coalition from a losing one to a winning one when they vote. Right? So what this means is that, say P3 votes, player 3 votes first, and the coalition doesn't have enough to pass, whatever the measure is. And then player 4 votes second. And remember, player 4 is going to have the least number of votes of anyone because they go in descending order. So player 4 maybe, still doesn't have player 3 and 4 together, maybe still don't have enough to pass the measure. And then player 1 votes third, and all of a sudden, the measure passes. Regardless of how P2 votes, right? It doesn't matter what P2 says after this. The measure is going to pass after P1 votes, purely hypothetically speaking. All right, so in that case, because P1 is the one that switched this coalition, this completely made-up coalition from losing to winning, we would underline P1 and say that P1 is pivotal. All right, so this is how you would write out all these coalitions and figure them out that way. Number of times that each player is pivotal, that is. You would figure them out that way. And then you would calculate the SSPI for each one of these players by figuring out how many times each player was pivotal, divided by the number of times that anyone is pivotal. And I did mention one little thing down here, which is that the number of times anyone is pivotal, very specifically for the sequential case only, is going to be n factorial, where n is the number of players. And the reason why is something Antonio pointed out in class last Monday, which is that the number of times that anyone is pivotal, well, there's going to be exactly one pivotal player per sequential coalition. And we know exactly how many sequential coalitions there are. There are going to be n factorial of them. Therefore, the number of times that anyone is pivotal is just going to be the total number of sequential coalitions, which we know is going to be n factorial. All right, so that's the one nice thing about the SSPI, is that its denominator is always going to be number of players factorial. Okay, so that's one nice thing about it. There are other ways that we saw how to go about sequential problems like this. All right, so one thing I would recommend that you do is revisit this, the city council and mayor weighted voting system. Right, we did an example where there were 4 city council members and a mayor, and we had the passing conditions written out in just plain English, just in words. There was no math in the problem at all. At least, not written out in a mathy way, I should say. So it was basically just a word problem. And we didn't come up with a weighted voting system, and we didn't write out all the possible coalitions because there would have been 120 of them. And there's no way we're doing that by hand. So we had some clever ways of getting around the fact that there were 120 possible things in that example. So I would encourage you to revisit that example as a way of tackling sequential problems without writing them all out. And we also did this contract negotiation problem where there were 3 managers, I think. 3 managers, that's right. There were 3 managers and 4 workers that were present at a contract negotiation. And we wanted to figure out the BPI, so the non-sequential power index for each one of the players. And because there were 7 players, there were going to be a lot of even unordered coalitions. There were still going to be a lot of them. And so we had basically some shortcuts, maybe you want to call them, for tackling all the combinations of these players, figuring out all the different winning coalitions in that case. And that was the unordered case, right? This contract negotiation problem was unordered. So I encourage you to go back and look at those two. Those are almost certainly the hardest two weighted voting examples that we did. Okay, so that's all I wanted to say about this. Basically, just to give you it's a roughly 26, 27-minute video, but I just wanted to give you a sense for all the things that we did, hopefully jog your memory, and at least give you some ideas for things that you maybe have gotten a little rusty on that you need to go back and revisit before we take this this online exam. Okay, so please, ask me any questions you have, send me emails, however you want to get in contact with me, let me know, and I am happy to answer any questions you have.